Hello everyone. In this video, we'll try to understand Maxwell equation. This is from the subject EMT. Before starting this, let us understand about these two theorems, Divergence theorem and Stokes theorem. So, according to this theorem, you can convert volume integral into surface integral by using this formula. And here you are converting line integral into surface integral. Also, you must be aware of this, that if divergence of any vector is 0, then it is known as solenoidal, and if curl of any vector is 0, then it is known as irrotational. This was just basic knowledge. Now we are going to study all the four equations of Maxwell equation in both time varying and static conditions. So first we'll find for time varying condition. In this, both electric and magnetic field are time varying. So these are the four Maxwell equations for the time varying condition. First is the Gauss law, which shows the relation between the charge density, volume charge density, and the flux density. So in differential form, it is written as this. So now we are going to integrate this triple times because it is volume integral. Then we'll get here. Now this is the total charge enclosed. It is the charge density. And then here what we are going to do is write this. And now using divergence theorem, this will equal to d dot ds. So this is the required equation. Now the second equation, which is divergence of magnetic field density is equal to 0, and this is due to the fact that the magnetic monopole doesn't exist. So now similarly we are going to write it in integral form, which is b dot ds is equal to 0. This one was quite easy. We used divergence theorem in these two equations, and in these two we are going to use Stokes theorem. Now curl of electric field, its double integration would be curl of electric field, and you can convert surface integral into line integral using Stokes theorem as this E dot dl. So E dot dl is equal to minus del upon del t and surface integral of B dot ds. And similarly in this case, H dot dl magnetic field is equal to surface integral of j plus del d upon del t into ds. This is for the displacement current, and this law is known as Ampere circuital law, and this law is known as Faraday's law. So now let us consider for the static condition. First two equation will remain as it is, and now in third equation you can derive Maxwell equation in static condition by using Maxwell equation of time varying condition. Just like this. Here, since it is static, therefore del by del t, you know that differentiation of any constant is 0. So this whole term will become 0. And similarly, this will become 0. So all this term will become 0, and this will also become 0. So curl of electric field will be 0, and E dot dl would be also 0, and this will known as conservation of electric field, since magnetic field and electric field are constant or static. And here only J will present, and so H dot dl would be equal to surface integral of JDS, which is current density, and this will be known as Ampere's law. So you can see that by using Maxwell 4 equation for time varying, you can derive other 4 equations in integral form and then for static conditions also. This single topic covers a lot in EMT, and now we are going to solve few questions on this. Okay, so this question is from IAS 2008. Consider the following three equations. Equation 1, 2 and 3. Which of the above appear in Maxwell equation? So this, yes, this was the non-existence of magnetic monopole, and this was Ampere's circuital law, and this was Faraday's law. So yes, all the three equations are present. Option A is correct. Okay, so this question is from IAS 2004. You have to match list 1 with list 2. I'm not giving any options. We are doing like this only. So here, A is continuity equation. We haven't studied it yet, so leave it. Now, Ampere's law, which is this one. Actually, it is Ampere's circuital law, but there was misprint or some mistake. You consider this as Ampere's law here. You have to consider it like this only, B1. Now displacement current. So you know that this is known as displacement current. So C2. Now Faraday's law. Faraday's law is nothing but this. You know this is Maxwell's third equation in time varying condition. So D3, and therefore A is 4. So it is continuity equation. We haven't studied this yet, but still we answered this question because we were aware of 4 Maxwell equation in both the conditions. So this is our last question and it is from IAS 95. Now this is very easy. So this was what? Ampere's law. 3. This is what Faraday's law, and this is Gauss. So this is the answer. So I guess you have realized how important these equations are. Please do try to remember all the equation and in both the form and in both the conditions. Thank you.